I left you with this series of questions related to how to modify your code blocks to substitute certain letters of the alphabet with other letters of the alphabet. And I hope you can see how this is building up to through what you might call a substitution cipher towards the idea of being able to encode and decode secret messages. So my first question was, could you take the phrase "the quick brown fox" and capitalize the initial letters of every word, making sure that the microbit displays the entire phrase? So here's a possible solution. I hope it looks fairly similar to my example code, which included the message you could set, and then special logic if a character from that message at a particular index equaled something. Some of you may even have got just about this far. You may have realized that you needed your message to be longer because there are more letters in the phrase "the quick brown fox." So the number of indexes you'll need corresponds to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. I may have miscounted, but something like 19. The rest of the logic is fairly similar. You want to go through and when a particular character that corresponds to T for the, and Q for quick, and B for brown, and F for fox is reached as you loop through the indexes, you're going to want to make a substitution of the capital version of that letter and show the string to the screen, the microbit screen. We had previously also shown the index, but that was mostly just to demonstrate to you how this brown block changed an index to a character. Now we can drop showing the indexes and just show the characters. So if you got this far with your code and tried it, you may have been surprised or disappointed to see that there's a problem. You are displaying the capital letters from the phrase "the quick brown fox," but you aren't displaying the rest of the phrase. And so maybe, I hope, you thought about this carefully and thought, okay, well, what I need to show are the other letters in an else block. It's not necessarily straight away immediately obvious how you show the other letters, but what you want to do is, as you loop through the index, remembering that in the past we'd also been showing the index here, but we've just got rid of this now. What you want to display is the character from the quick brown fox from message that corresponds to the particular index as you loop through. So think about it like this. When we're at index 0, the character at index 0 from the message corresponds to lowercase t. We'll show the uppercase T. But when we're at index 1, well, the character is equal to lowercase h. So this condition isn't met, this condition isn't met, this one isn't, and this one isn't. You needed an extra statement, an else statement, saying, okay, when none of those conditions are met, we're going to display the character anyway. We're just not going to display the capital version of the character. We're just going to literally display the character itself from that index. And so when it's 1, when it's h, we're going to show the character from the quick brown fox that is at index 1. Index 1 is h. When it's 2 the index, as we loop through, index 2 is e. Again, these won't be met, these various logic statements. We're going to show the character from quick brown fox in index 2. We're going to show the e. So this else statement was critical, as I hinted at in the example, to showing the full phrase. So let's try it, and now you'll see we do show the capital letters, but we're also showing everything else as we loop through the indexes in the message "the quick brown fox" to display the corresponding letters. Excellent. So that was the first answer. Some of you may have been clever and thought, well, what was all this talk about length of message? Here I had to count 0, 1, 2, 3, and I got something like 19. Maybe I miscounted, maybe I didn't. But you can just get your microbit to do this for you. this length of some variable, could be any variable, but this length of the particular variable is how many characters are in it. So the length of message corresponds to, maybe 19 is right, maybe it's wrong, doesn't matter. I'm just going to let the microbit do this for me. Technically, you need length of message -1 because we start at 0. And so going from 0 to the final character, you actually want the total number of characters -1. But let's think about that tomorrow. It's fine for now just to have length of message. So if you achieved this solution or something similar to this solution for the first question, the next question was to, instead of just substituting T for capital T, Q for capital Q, B for capital B, just do some other substitutions. Turn the Q into a T, the U into an H, and the X into a G. So the code to do this looks very, very similar to that previous code, but instead of swapping things, notice I've already put the length of message in there. Instead of swapping things with capital letters, we swap the Q with a T, the U with an H, the X with a G. So when this logic is met, Q becomes T, U becomes H, X becomes G. Still have to show the other characters. Very, very similar, just different substitutions. So when you play this, what do we get? Well, the Q is going to become a T. So quick, you're going to get twick, but the U is going to become an H, so quick is going to become thick, and any X's are going to become G's. So you're going to get the thick brown fog. So let's check that we got the right answer. The thick instead of quick. Brown is left the same because there are no letters to substitute, and then the X becomes a G, fog. So I hope that's a very simple extension of the previous example. Finally, I asked you to take the resulting phrase, which is the thick brown fog, and turn it back into the quick brown fox. And you may have thought, well, this is very simple because all I have to do is, you asked me to swap a Q with a T, a U with an H, and an X with a G. So I can just swap a T with a Q, an H with a U, and a G with an X. Just go in reverse. T's become Q's, H become U, G's become X's. The thick brown fog will become the quick brown fox again. I need to elevate this block so it's the one in color that's actually running. So let's look at this message again and see what we get. You're expecting the thick brown fog to turn back into the quick brown fox, but instead you get QUE, K, quick, K quick brown, K quick brown fox. So it's almost right, but instead of the quick brown fox, you have K quick brown fox. So you end up with K quick brown fox like this. Why is this difficult to turn it back? Well, it's because in the quick brown fox, you actually have, if you try and substitute Q with T, not a problem, there's one Q. If you try and substitute U with H, not a problem, there's only one U. X with G, not a problem, there's only one X. But in the phrase, the thick brown fog, let's just type it. If you try and substitute the T with a Q, you have a problem because there are two T's in the phrase, one here and one here, hence K quick brown fox. So it wasn't as easy to turn it back into its original phrase. And you could have done it with very complicated logic, like unless it's the first index, unless it's the 0th index, do something special, and maybe you embarked upon that. But what I really wanted to demonstrate with this code is it's not necessarily unique when you create a cipher. When you substitute things to create a code, to encode a phrase, going back in the other direction can be tricky because what you create as your algorithm, as your method for moving from a phrase to an encoded phrase, moving back in the other direction, the reverse algorithm may not create a unique phrase. all of this week, I'm going to focus on you writing your own code. But depending on what grade you teach, you don't necessarily even have to open up your microbit to show examples like this. You could imagine an entire lesson where you ask the students to create the algorithm. What are the steps needed to turn, say, the quick brown fox into the thick brown fog? And they could come up with the steps, the algorithm, change this into this and this into this. And then ask them, change it back. And they would find that they can't change it back for the reasons I've just described to you. They would get K, quick brown fox. So some of these concepts of encoding and decoding, you can explain those and describe those in the class without even needing to have your students write code.